One thing about human is that everybody tends to make things very hard for the other person. Every generation tends to make things very hard for the next generation. They just want to act superior and make it look like they were the wisest generation around. Do you know this equation, the energy to mass equation by Albert Einstein? If you go online or textbook, you will see them speaking so much English trying to explain rubbish. I'm sure the day Albert Einstein explained this to them, he just told them a simple thing. Now they won't say it the way he said it. They will just start making things complicated. Speaking English like, say, Albert Einstein did a very big thing. Albert Einstein didn't really do too much. I think he just followed the normal basic physics principle. Let me show you something. Watch. Now, the force acting on anybody is the product of its mass and acceleration. That's the mass of the body multiplied by the acceleration to which the body would move. This will be in the direction of the applied force. So let's call that mass times acceleration. So from what you can see here, you can see that energy is the same thing as force times distance moved. And again, force is equivalent to mass times acceleration. The force acting on the body, or the force applied in the body, is the product of the mass of the body and the acceleration due to the force. And this force is this acceleration is in the direction of the applied force. Therefore, energy is force times distance. This is the same thing as the work done by the system of force. And force is mass times acceleration. Okay, that is it for the force acting on the body. How about the energy acquired by the body due to the force? Now the energy acquired or possessed by the body due to the force is the product of the force and the distance moved. That's force times distance. This is the same thing as the work done by the force, or the system that was initiating the distance moved. Therefore, we can say that energy is force times distance, and force is mass times acceleration. So by substitution, you can now see that by substitution, since energy is force times distance and force is mass times acceleration, therefore energy is force times distance, where force is mass times acceleration. We have substituted that. At the end of the day, you can see that energy is mad. This is funny, this is the joke, and it's not a joke actually. Still listen. Energy is mad, where M stands for the mass, A stands for acceleration, and D stands for the distance moved. Now I want to show you something. Again, we all know that the acceleration of the body is the ratio of its velocity with time. Acceleration is the change in velocity with time. So we can say that acceleration is velocity over time. So let's note this as well. That's acceleration. Now, what is distance? Distance is related to speed. Distance traveled by a body is the product of the speed or velocity with time. So the speed of velocity and time is the distance traveled by a body. Are you listening to me? So when you multiply velocity with time, you get what is called distance. So the distance in this math, we can replace it with the product of velocity and time. Let's know this as well. So from what you can see here, you can now see that energy is the product of mass, acceleration of the body, and the distance traveled by the body, isn't it? Let's go ahead. Now, from the general equation of relativity between mass and energy by Albert Einstein, it states that the energy acquired or possessed by a moving particle is the product of its mass and speed, the square of speed. Now the speed there, every quantum particle is estimated to move with the speed of light. Therefore, we can represent the speed of velocity with c, which stands for the speed of light. This is a constant. If we do this, then watch what happens to energy, being the product of mass times acceleration times distance moved. Hey, from the general equation, you can see that energy is equivalent to the product of mass and the square of speed. Therefore, from what we had before, where energy is equivalent to mass, we can keep m, then see what we can do to acceleration times distance to turn to c square. So let's continue. Now, from Albert's equation, the popular equation that states that energy is equivalent to the product of mass and the square of velocity of light or speed of light. Now, if we decide to keep or fix the mass of the body from here, let's fix the mass. Let's see what A and D can become. Watch. We all know that acceleration is the ratio of velocity to time, and everyone knows that the relationship between velocity, time, and distance is that velocity is equivalent to the ratio of distance with time. Therefore, distance is the product of velocity and time. Now, by substitution, we know that energy is MAD. M is fixed. Remember, V over T is equivalent to acceleration. That's A. Now, what's D? D is VT, and we put VT. When we multiply all this, what do we get? mv square t. This is m. V times v is v square t. Now, when t cancels t, what we have is mv square. Are you looking at this? Now watch. So therefore, E is equivalent to what? So from here you can see that E is now what? The product of mass times what? The square of what? Velocity. Now in quantum physics, every small particle, they usually have what? Negligible what? Masses. They move with the speed of light. That's their approximate speed. I listen to me now. Therefore we can replace this velocity with what? Speeds. In this case, that of light. Therefore energy is now what? The product of mass and what? The speed of light, where V is equivalent to what? Velocity, and C is what? Speed of light. And we know that velocity is what? Equivalent to speed. The difference between them is that velocity is a vector while speed is what? A scalar quantity. In this case we have the speed of light. That's it. So this is how this man came about this, and people went ahead to be making it look like the man was making too much magic. The man was not making too much magic. So this, you can apply it anywhere, both in lost electron in an atom. You can actually apply it. You say that the energy possessed by the electron can be what? Mass of the electron times the speed to which the electron is what? Moving. Under the topic photoelectric effects on displaced electrons, this is also the what? Amount of energy they what? Acquire or they possess. So people should stop making simple things look hard for others. I do not like that. This generation is fond of that. Mostly the last generation, not the past one. The past ones made things easier for them. Why they just try to make things very hard? This is not good at all. So from here you can see that it is not really hard. It is actually this oversabi people that makes things look as if they are very hard. I'm sure most of the things I also find hard today, both in computing, physics, chemistry, is somebody that did I too know. I went and write them like that, and once I discover it, I'll dismantle it and show you guys how it is done. Very wicked people.